Hello students, I welcome you all in the e-learning classes of physics, and in this video we are going to practice some numerical problems on the topic potentiometer. As you know that in our last video we have discussed about potentiometer, which is the very important topic of chapter 3, current electricity. So today we will do some numerical problems on this topic, and before doing the numerical problems on this topic I would like to remind you one thing, that in any of the problem in potentiometer you first better to calculate the potential gradient of the potentiometer. And as you can recall from that video, that potential gradient is the voltage drop per unit length of this wire, which is denoted normally by AB. So first we will calculate the voltage drop on this wire, and thereby we will divide that voltage drop by the total length of the wire, and we will get the value of potential gradient, and this value will be utilized in further calculation of the question which is being given. Okay, so I have taken this very first question from CBSE exam, and this question, first we will read out this question and thereafter we will try to solve this question. So this diagram has been given. So this is the voltage 3 volt of driver cell, and this is the value of resistance box, or we can say the resistance we have used from this resistance box, that is 290 ohm. So if you can remind, here we have connected the resistance rheostat, but instead of using rheostat, here the fixed value of 290 ohm is being used. And this is AB wire whose length is given as 400 centimeter, means 4 meter, and the entire length of this wire consists of in total 10 ohm resistance. So in the secondary circuit, this V voltage has been given, which we have to find out the value, and corresponding to this V potential, the balance length is 240 centimeter, means the deflection in galvanometer becomes 0 when the jockey reaches at 240 centimeter from point A. So this much of information have been provided in this diagram. Let us try to understand this question. So find the potential gradient of the given potentiometer. In this we have to find out the potential gradient, in fact, but if it is not been asked, then also you have to find out the value of potential gradient, because this is the main parameter of any potentiometer. So we have to find the value of potential gradient of this given potentiometer, and unknown potential V. This is unknown potential corresponding to which the balance length is 240 centimeters. So we have to find out the value of this EMF. Okay, and if the zero deflection occurs at 240 centimeter, which we have already elaborated. Okay, so how to find the potential gradient in a potentiometer or of a potentiometer? So potential gradient depends only on the primary circuit. So what is the formula for potential gradient? So as you can recall from the last video, that potential gradient is denoted by K, and it is the total voltage drop on wire AB divided by total length of wire AB. So total length is given as 400 centimeter. We will use it, and VAB we have to find out. VAB is the potential drop on the entire length of this wire AB. So we can find out the potential difference or potential drop if we have the value of current flowing in this primary circuit. So can we calculate the value of current? You will say, of course, yes. I is equal to total EMF of the driver cell, that is 3 volt, divided by total resistance of primary circuit. So total resistance of primary circuit is 290 plus 10 ohm, that is 300 ohm. So 3 divided by 300, this comes out to be 1 upon 100 ampere. So this is the value of current flowing through the primary circuit. Now we will use this value of current to find out the voltage drop on V on this wire AB. So this will be VAB is equals to I into R AB, and I is, we have already calculated, 1 upon 100, and R AB is given as 10 ohm, so multiplied by 10, so it comes out to be 1 by 10 volts, which can be written as 0.1 volts. So this is the value of voltage drop. Now we will put the value of VAB in this equation. Suppose this is equation first, and we can calculate the value of potential gradient. So this value is 0.1 divided by length is 4 meter or 400 centimeter, whatever you like. So I am putting the value in meter, so it will come out to be 1 by 40 we can write down here, and it is volt per meter, not volt per centimeter. If you use 400, then volt per centimeter, otherwise volt per meter. So this is the value, desired value, which have been asked. Okay, now the second part, we are coming on to the second part. In second part, we have to find out the value of this V, for whose this balance length is 240 given. So if you can remind the very first application of potentiometer to find the value of unknown cell or EMF of unknown cell, so it was V or E is equal to K into L, where K is the potential gradient and L is the balance length. So here the value of E is given as, or in place of E it is given as V, so V is equal to K into L, and K we have already calculated 1 upon 40, and balance length is 240, but it is in centimeter. So since we are using this K in volt per meter, so we have to convert that centimeter into meter, so it will be 2.40 meters. So you can cancel out, or you can write down this as how much, 1 upon 40 into 240 upon 100. So 0 cancel out by 0, and this comes out to be 6. So 6 into 10 minus 2, which can be written as 60 millivolt. So the value of, the unknown EMF of the cell is 60 millivolt, or 6 into 10 is for minus 2 meters. So this is the answer, or desired answer in fact. So this is how this potential gradient will be used in solving the problems of potentiometer. So I hope this problem you have understood. Now we are moving on to the next question. So let us move on to the next question. Question number 2. Find the balance length L for which the cell of EMF 2.4 volt gives 0 deflection. So this is the balance length L. We have to find out the value of this length L for which this cell of EMF 2.4 volt is balanced or gives 0 deflection. And this circuit has been given to us. 6 volt is the EMF of driver cell, 10 ohm is the resistance connected with this 20 ohm resistance of this wire AB, whose length is given as 200 centimeter. So once again, as we have discussed in the previous question, that we have to find out the potential gradient. So what is the formula for potential gradient? Potential gradient K is equal to total voltage drop on wire AB divided by total length of wire AB, and it totally depends upon primary circuit, that is this circuit. Okay, so now balance length, total length of this wire is given as 2 meter, 200 centimeter means 2 meter, and the total resistance of this wire is 20 ohm. So first what we will do, we will calculate the current flowing through this primary circuit, and thereafter we will multiply that current with this resistance, and we can find out the value of VAB. So current flowing through the primary circuit I is equal to total voltage, that is 6 volt, divided by total resistance 10 ohm plus 20 ohm, 10 plus 20 comes out to be 6 upon 30, and it can be written as 1 divided by 5 ampere. So this is the current flowing through the primary circuit. Now the voltage drop across wire AB will be current multiplied by resistance of wire AB, and current is 1 upon 5 and resistance is given as 20, so it comes out to be 4 volts. So the voltage drop on this wire AB will be 4 volts. Now we have to calculate the value of potential gradient. So using equation first, K is equals to VAB, that is 4 volt, divided by total length, that is 200 centimeter, which can be written as 2 meter. So 2 volt per meter is the value of potential gradient. Although this was not been asked, but as we have discussed earlier that in the question of potentiometer, this you have to find out always. Okay, now using the value of this potential gradient, we can easily write down the equation. The EMF of this cell, that is 2.4 volt, will be balanced by this length L. So thereby we can write down that E is equal to KL, and E is given as 2.4 volt. K we have already calculated as 2, and we have to find out the value of this balance length L. So L will be 2.4 divided by 2, that is 1.2 meter, or we can say this is 120 centimeter. So this is our answer. So I hope now you are getting confidence in solving the numerical problem of potentiometer. Let us move towards some different type of problem and next problem. So we are moving on to the next question, question number 3 of potentiometer. And in this question, this diagram has been given, and what has been asked, we try to read it out. How will the balance point C, this is the balance point C where the deflection in galvanometer becomes 0. So how will the balance point C shifts when first question is asked R is increased. This is the resistance R. So if we increase the value of this resistance, how this balance length or consequently the balance point C shifts as we increase the value of R. And second question is being asked that S is increased. If S is increased without changing the value of R, then how the balance length will increase, decrease, or will remain same. So this is the question. Okay, so first we try to check that when R is increased, what is the effect of this increment. So if R increases in this circuit, then definitely current will decrease, because the formula of current is I is equal to the total EMF of driver cell divided by total resistance. So resistance is R plus the resistance of this wire AB, and suppose the resistance of this wire AB is RAB. Although this value has not been given, but it is not necessary here. So RAB plus R will be the total resistance. So this will be the value of current. Now see, if I increase the value of R, resistance R, if this value is increases, then definitely the value of current decreases. Okay, so what is the effect on the value of current flowing through the primary circuit I is that if we increase the value of this resistance, then definitely the current flowing through the primary circuit will decrease. And if current flowing through the primary circuit decreases, then voltage drop on wire AB, that is VAB, is equals to I into RAB. So if I decreases, then definitely this value also decreases, or VAB also decreases. So the value of VAB decreases. Okay, now what will be the effect of this decrement of VAB on potential gradient? Since we know the formula for potential gradient is K is equal to VAB divided by this total length of the wire AB. So as VAB is decreasing on increasing the value of R, thereby K will decreases, and if K decreases, then we know that this EMF of the cell is balanced by balance length L, so E can be written as K into L. So if K decreases, if this K decreases, then definitely L have to be increased so that the product may remain constant, because this cell is not going to change, only we are changing the value of resistance. So what is the effect of increment of this resistance on the balance length? So you will say since K decreases, thereby L increases, so L increases, we will say balance length increases, or in other words, this balance point C will shift towards B point, or in other words, what we can say, point C will shifts towards point B. So this will be the answer of very first part. Okay, now we will talk about the second part, and the second part is that if we increases the value of this resistance, so what will be the effect on the balance length? Okay, now from here you can you know make a point that if we change E, then definitely balance length will change, and if we uh, we make any change in the primary circuit, then this K will change. So the change in potential gradient totally depends on the change on primary circuit, and this balance length is dependent on the value of E. So this resistance S is connected in series. So when this deflection becomes zero, or when there is no current flowing through this loop, then is there any use of this resistance? So you will say there will be no use of this resistance. So for the sake of balance point, there is no use of this resistance in the circuit, because at the balance length or at the balance point there is no current flowing through this loop, and if no current is flowing through this loop, then definitely there will be no voltage drop on this resistance, and therefore there is no significance of increase or decrease in the value of resistance, or we can say the balance length will not change on increase or decrease of this resistance. So the answer for the second part will be balance point or balance length will remain as it is. Balance length will not change. Okay, now let us try to extend this question up to next level. If this resistance is not connected, suppose here, and this resistance is connected, for example here, now can you estimate that is there any change in the balance length if I increase the value of this resistance? So now since this resistance is connected here, so now the terminal voltage of this cell will work, because now the circuit is complete, and in this circuit definitely some current is flowing, although there is no current in this circuit, but so far as this circuit is concerned, definitely some current is drawn from this cell by this resistance S, because now this resistance is connected here instead of here. Okay, so now the balance length L will be corresponding to, we can say, the terminal voltage. So I can write here V is equal to K into L, although K is constant because it depends only on the primary circuit and there is no change in the primary circuit. Okay, but what about V? So if I increase the value of S, then definitely the value of current will decrease, and there is a relation in EMF, terminal voltage and internal resistance of the cell. V is equal to E minus IR, as you know. So if I decrease the value, or if I increase the value of this resistance, then definitely current will decrease. So current will decrease, and if current will decrease, then definitely this V will increase, and if this V will increase, then if this is increasing, this is constant, then definitely balance length should be increased. So here the question will change. If this resistance is connected here instead of here, then definitely now the terminal voltage will change on change of this resistance because current is changing, and thereby the balance length will increase if this resistance increases. So the balance point will be shifted towards B. So this will be the answer in that case. So you must remember, or you must watch first, that this resistance S is connected here in the series of this battery cell, or we can say in the secondary circuit or in this circuit, like this. So if this this resistance is connected here, then definitely there will be current flowing through this circuit, and when we are drawing some current from the cell, then EMF, or the potential difference between cathode and anode, is not EMF, it is actually terminal voltage, and this terminal voltage depends upon current. So this is how you will solve such type of questions. So this is very important questions, and frequently asked in CBSE exams. So you must care about such type of questions. What will be the effect of this resistance? We can say if we increase the value of this resistance, the balance length will increase, and if we increase the value of this resistance, the balance length is also been increasing. But if I put this resistance here in series with this cell, then there will be no effect on the balance length of the cell. So this is the summary of this question. So this is very important question. You must practice this question before going into the final exam. Okay, let us try some other questions.